Greetings once again. Welcome to another edition. In this session, we'll be looking at the Maths 2023 November paper 1, specifically question 3. So question 3 is still based on series. So let's have a look at what they expect. So question 3 reads, given the geometric series 3 plus 6 plus 12 and so on to n terms, 3.1.1, write down the general term of the series. So essentially the question which they are asking us for 3.1.1 is, what is Tn equal to? That is what they mean when they speak of the general term of the series. So let's quickly have a quick reminder of what is going on here. So we are told, number one, that this is a geometric series. So by virtue of being told that this is a geometric series, we should remember that our Tn equals a to the power of, or a multiplied by r to the power of n minus 1. What is a and what is r? A is the first term of the series, or the sequence. And our r is our ratio, which is always given by T2 divided by T1, which will be the same as T3 divided by T2. So as long as you have two consecutive terms, when you divide them, you will just always find the ratio to be the same when the series is a geometric series. So what we can clearly see from our problem is that we have a 3 plus 6 plus 12 plus and so on. So we can clearly see the first term, which is a. So that there should be our a. So which means our a will simply be 3. Now we need to go and find our constant ratio, which is the same as dividing T2 by T1, and this is the same as dividing T3 by T2. So if you look at our problem, you should see that our T1 is 3, our T2 is 6, and our T3 is 12. So when we're looking for our r, we'll divide our T2 with T1, which is 6 divided by 3. And this should give you the same answer as when you divide T3 with T2. So if you look carefully, the constant ratio will be 2. So which means we can now write our general expression Tn, which will be our a we found as 3. So it will be 3 multiplied by 2 to the power of n minus 1. This is the solution which they are looking for the first question. Now let's have a look at the next question, which is question 3.1.2. So if you look at the question, they say calculate the value of k such that that series there, so remember that the sign or that sign there stands for summation. So essentially it stands for summation, so we are summing. So essentially what we have there is a series. So we need to solve for the value of k. And what is the value of k? Well, what you need to understand is the number of terms which we are summing. So the number of terms which you are summing on the series when you are dealing with this sign here will always be k minus the bottom number, which is 1. Minus the bottom number, which is 1, which means we'll minus 1. Then you always add 1. So if you look carefully, this will just give us k. So essentially what we'll be doing there is we'll be finding a sum, and we'll be asking ourselves how many terms did we sum, which is what k stands for, such that the sum becomes that. So let's expand that series which we have there. So we have k is 1. Sorry, we have p is 1. And our equation is 3 over 2 into 2 to the p. So when we substitute p is 1, what you will see is that we'll have 3 over 2 multiplied by 2 plus. We'll substitute 2 now, so that what we'll have is 3 over 2, 2 squared. And we will substitute 3 as p, so that we'll have 2 cubed, and so on. This will carry on until we get to whatever term or k value which we are looking for. So let me make some space and we quickly write that. So this summation or this sum will carry on until we reach the last term, which will be 3 over 2, 2 to the power of k, like that. But what we need to see is that when you quickly do the multiplication here and here, you'll have cancellation. So you'll have a 3 plus. If you go and look at this one, you'll have a 2 cancelling, then there'll be 1, 2, which will give us a 6. Plus, if you look at the next term, it will give us a 12, and so on until we reach that last term there. So if you look at this series, it is exactly what we had. So we just need to find the sum and then solve for k. So for this series previously, we agreed that our a is 3 and our r we found is 2. So we know that when we are summing k terms, or let's start by putting n so that you become less confused. So if you remember, for a geometric sum, the sum is always given by a into Rn minus 1, then divided by r minus 1. So in this case, since we are dealing with k, we can just put k wherever we see n. So this will be a into rk minus 1 divided by r minus 1. So we know that the sum of k terms will give us the number which we have there, 98,301. So let's go to the next page and deal with that. So we know that the sum of k terms should give us 98,301. Let me just confirm. Awesome. And we know that the sum of k terms is a into Rn minus 1 divided by r minus 1. So let's go and substitute the a. So the a, we know it is 3. The r, we know it is, need to put in a k here. The r, we know it is a 2. Then we'll have that, and then we'll have 2 minus 1. So our summation will end up being 3 into 2 to the k minus, when you multiply, it will be 3 like that. So remember, we are trying to solve for k here. So therefore, what I can now do is I can have 3 into 2 to the k minus 3 equals that there, which is 98,301. Remember, we are trying to solve for k, so we are going to transpose. And when we transpose, you'll just take the 3, push it to the other side, and that will end up being 98,304, like that. And then what we want to do is to be able to divide by that 3, because what we are trying to solve for is k. So I'll have 2 to the power of k equals, let's quickly get our calculator. So if you look carefully, we're going to have 98,304 divided by 3. And that there, if you look carefully, will give me 2 to the power of 15. So I'll have 2 to the power of 15, as you can see from my calculator. And what we know is that when the bases are the same, it is easy to equate the exponents. So as you can see, our k will be 15. So this means that we need to sum 15 terms for us to be able to find that sum which is given there. I hope this makes sense. Let's now have a look at the next question, which is question 3.2. So the question reads, a geometric sequence and an arithmetic sequence have the same first term. Okay, that we understand. And then they further tell us that the common ratio of the geometric series is 1/3. Okay, so let's quickly note a couple of things here. So the A is equal to the A for both the geometric and the arithmetic sequence. And then if we look at the second part, they say that the common difference of the arithmetic sequence is 3. So what we need to note is that this means that we have a D value of 3. That is how we denote the common difference for an arithmetic sequence. Then the last statement reads that the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. So let's go and make a couple of notes regarding that statement. So for the geometric sequence, we need a sum to infinity. While for the arithmetic sequence, we need the sum of 22 terms. So if you look at our statement, it says that the sum of the arithmetic sequence is 734 more than the sum of the geometric series, which is the geometric sum to infinity. So what this means is that our S22 will be the same as the sum to infinity plus that 734. This is what that statement means. And the question is, lastly, we need to calculate the value of the first term. So the first term, we know that it is A. So the first thing which we need to do is to quickly write what is the sum to infinity for the geometric series. So we know the equation is always given by A divided by 1 minus R. So our A is unknown, so we'll leave it as it is. Then 1 minus our R is known. So if you look up there, we're actually given that our R, which is the geometric or the common ratio, is 1/3. So I'll have 1/3 like that. And this will be equal to 3A divided by 2. So when you simplify that, that is what we get. And then let's go and have a look at the sum of 22 terms. So what we know is that the sum of a geometric series is just always given by n/2 into 2a plus n minus 1 times d. So if we're looking for the sum of 22 terms, we'll have 22/2 divided by 2a, the a we do not know, 22 minus 1, then the common difference we're given as 3. So if we attempt to simplify here, what you should be able to see is that when we do the multiplication and the simplification here, 22 divided by 2, that will be 11. Then you'll have 11 times 22 or 2a, this will give us 22a. Then plus, what you will have will be 11 multiplied by 21 times 3. And that will give you 693. Okay, that is what we are getting as our sum for the 22 arithmetic terms. So now that we have this, we can now sub back. We can now substitute back to the expression which we wrote, which was S22 is S infinity plus 734, because they said that the sum of the 22 terms is 734 more than the sum to infinity. So let's sub back. So what we have is 22a plus 693 equals, the sum to infinity is 3a over 2 plus 734. So we can transpose and have 22a minus 3a over 2 equals 734 minus 693. So let's quickly get our calculator to help us quickly do the easy subtraction which we need to do here. So if you look carefully, we have 22 minus 3 divided by 4. And that becomes 41 over 2. So it becomes 41a over 2. Then on the right hand side, we have 734 minus 693. And what we get there is 41. So if you look carefully, we can now remove the fraction, which is that 2, by simply multiplying by 2 both sides. So I'll need to multiply by 2 and by 2. And what you should see is that we'll end up with 41a equals, when you multiply that by 2, it becomes 82. Then we can now find a, because we just need to divide both sides by 41. So if we divide by 41, you should be able to see that the a value which we will find will be 2. And guess what? The a value, we said it is the first term. So therefore, the first term of this series will be 2. That is how we're supposed to answer that question. And whoever is doing the marking would be very happy of us. So make sure that you understand the fundamentals, because these questions, they just mix things there and there. And as you can see, here they combined the geometric series and the arithmetic series. So make sure that you don't find yourself confused. I hope this was clear and it helps. Enjoy.